What's the picture for?
This is all the water in the world.
I'd heard there was a shortage.
I mean, it represents all the water in the world.
In the freshwater kit, the kids learn that there is a limited supply of fresh water and that using it wisely and taking good care of it is everyone's responsibility.
So we take 7 tablespoons of water and add it to this cup. This represents all the fresh water that we have. This pitcher represents all the salt water that's in the oceans.
Hard to believe.
I know. And 4.5 tablespoons of the fresh water stays frozen all year long at the North and South Poles and other cold places. Hand me the lakes and rivers cup.
Sure. Those 10 drops of water represent all of the water in the lakes and rivers. And so the rest that's left in this freshwater cup is all underground.
Yep. These 2 cups represent all the fresh water that people use. You'll do this demonstration at the beginning of session 1. In the rest of the session, the kids measure how much water drips from a model of a leaky pipe using a bendy straw and a dropper like this.
We use a lot of models in the freshwater kit, and a model is a copy of something that's different from the real thing in at least one way. In science, people use models to explain, test, and understand things.
And with this model, they can see how much a tiny drip can waste.
In session 2, you do a demonstration during Engage to find out how much water comes out of a faucet in 30 seconds.
Then the kids play a board game that shows them how they can use less water every day.
In session 3, you start to explore groundwater. Now, groundwater can be hard for people to understand, so you start with a demonstration.
So this sponge represents the ground. And this is the rain coming down. The water seeps into the spaces of the sponge. Groundwater moves between bits of soil, just like the water inside the sponge.
There are some lakes and rivers underground, but mostly groundwater just fills in those tiny spaces between rocks and bits of soil.
During the rest of session 3, kids work in pairs to explore a different model of groundwater.
Here's a hill, here's a lake, and here's the groundwater. At the end of the session, the kids find out what happens when you add pollution.
In session 4, the kids test water samples and do a pollution test.
You set up the samples ahead of time and put vinegar in some of them that will show up as pollution when you test for it.
At each station, pairs put 10 drops of the sample water into their sample cups, and then they add 10 drops of the tester into their cups.
This tester is called bromothymol blue. We'll just call it BTB. Now, BTB will change color if it comes in contact with anything acidic, like, say, vinegar. And it turned yellow. Not every sample will be as polluted as this one.
And make sure the kids clean their sample cups after each test. You'll set up 2 rinsing stations just for this. If the cup isn't clean, it can mess up the test.
And if you're worried about spills, you can do all these activities outside.
You may notice the kids playing with the droppers, especially the water, seemingly distracted by the materials. But often kids become engaged by materials like these.
Fascination like this is why some people become scientists. So giving kids time to explore and talk about what they're doing can be time well spent.
And when you're done with the activity, don't waste the water. You can use the water to water some plants.
Funding provided by Oracle, the Noyce Foundation, the S.D. Bechtel Jr. Foundation, the David and Lucille Packard Foundation, and the Stephen Bechtel Fund.